Hello guys, welcome you all in this new video, and today video is going to be very interesting because in this video we are going to discuss that how does the wireless charging works. You have seen that in these days there is a new trend going on towards the wireless charger. Wireless charger, and many times this question comes in our mind that what's the reason, and how it is possible without a charging pin or without a charging that wire you are charging your phone. So let's understand what's the reason behind it and which basic physics formula and principle and laws are used there. And how it works, guys. It's a very interesting phenomena. By the way, it's a very old concept. And this is the thing that in these days this is coming in the practical application. Either it is a very old concept. Let's understand how it works and how we can use this much more better way. This concept which is used in the wireless charging. So what are the basic principles that we will discuss? So let's start our video. So guys, let me share you with you a fact that like you have seen that wireless charger means what you have to keep your phone. For example, I take this is your phone. And you have to keep your phone within the range of your charger. There is no any wire between them, but yes, you have to keep within a certain distance, with respect to your charger, which is your charger point. Let's say this is your charger. So you have to keep your phone within a certain distance, with respect to that charger, so that it can be charged. So the concept here is that what is there which is transmitting from this charger to this phone. What is that we have to understand. And when that thing is transmitting from this charger to this phone, and what is happening inside this phone, what's the instrument which is established there, to make current or to generate electricity, type that phone. So this is the concept you already know. So we have to here explore what is this thing, which is transmitting from this charger to this phone. And now then after that we have to understand that what is happening here in the phone. Which phenomena is happening, and is there any law which define all these things, and if it is defined, then how we can calculate and how we can determine the range of how much will be the range of this distance that I will keep my phone at this much distance, it will get charged. So all these query will be answered in this video. So don't worry about it, it is going to be very interesting video. So guys, before I start my explanation regarding the wireless charging, you have to understand two very basic concept and very interesting concept, that is electromagnetic induction and Faraday's law, guys. So these are nothing, so don't worry about it. These are very simple and very interesting concept. Electromagnetic induction concept says that, guys, whenever you are changing there, basically if I tell you in a very simple language, you can say that by changing current, you can produce your magnetic field, or by changing the magnetic field, you can produce your current. So this is not the actual explanation, this is just I am telling you. For example, if let's say this is your wire, this is your conducting wire, and this is connected with a particular circuit. Let's say here is your circuit, this is your bulb, and what you are doing, there is a magnet here, let's say this is north pole and south pole. You are changing the position of magnetic field, this magnet with respect to this coil. This is coil and this is magnet. When the magnet is approaching toward the coil and moving away from the coil, there is the changing of the magnetic field with respect to this coil. This coil is conducting coil. Let's say this is the copper coil. So when the magnetic field is continuously changing in the copper coil, I'm talking about copper coil, magnetic field is generated because of this magnet, and it is changing or influencing what? A copper coil. Electromagnetic induction principle says that whenever this kind of phenomena happen, it means that there is a changing in the magnetic field in a particular conductor. There will be an EMF, electromotive force. So don't be confused, you just simply think that when there is a change in the magnetic field, it will produce current. how it will produce? There will be a change in the potential difference, and when there is a potential difference, okay, when there is certain potential, so that will leads to the generation of current. Okay, so this is simple concept of electromagnetic induction. And guys, you know about the one famous scientist and very respectable, okay, I respect a lot this scientist, and he was a genius, Nikola Tesla. Okay, Nikola Tesla was the person who even challenged the Thomas Edison. Okay, why? Because he always favored, he think that AC, alternative current, is much more better than the DC. Okay, as you know that Thomas Edison invented the bulb, okay, and he was a promoter of the DC current. He always thought that okay, DC will dominate the future of electricity, okay, but not. Nikola Tesla was the person who believed in the alternative current, and because of this person belief, and because of this person vision, okay, today we are seeing that electricity is reached at every place. Why? It's because of alternative current, because alternative current can be reached too many long distances. Okay, so alternative current is nothing, guys, it's like this sinusoidal wave, because it's a magnitude is going to vary with respect to the time, okay, like this, it's a periodic, you can say. Okay, so DC is nothing, it's a constant like this. Okay, there is a constant magnitude of it, it will not change with respect to the time. Okay, and not change in the sense means periodic change is there. Okay, so in the DC there is no kind. So this is a separate topic, but my purpose here is to say that why I am talking about Nikola Tesla. Nikola Tesla was the person who used this electromagnetic induction, okay, to produce what? To produce alternative current. How the alternative current is produced, guys? It's like this. Okay, here is your like say this is your plate, and I had wired up a copper coil or some conducting coil around it, and both side we have this kind of magnet, okay, and we rotate this coil in the magnetic field and we generate the electricity. That is called alternative current electricity. Okay, so that's a separate topic. Let's come back to our actual or original concept I am talking about, that is electromagnetic induction. Okay, electromagnetic induction, EMI talking. So electromagnetic induction, as we learned, okay, when there is the changing magnetic field, okay, it leads to what? Current. I means current. In the physics you showed the current with the I. Okay, so changing magnetic field leads to the current. This thing we know. Okay, now let's understand another concept, that is Faraday's law. What the Faraday's law says? Faraday's law, you know, you can say he systematically arranged all these phenomena in a mathematical expression. Okay, he said that EMF is induced when there is a change in the magnetic flux. Okay, so this is, let's say, N. So this was the expression which was given by the Faraday's law. Guys, whatever I am telling you, just use to sum up all these things. I will use all these phenomena to explain how the wireless charging works. Okay, I'm just explaining in this time the basic physics which is used there. Okay, so this was the, what's this E? This was the EMF, electromotive force. Okay, and what is this phi B, you can say phi B, this is the magnetic flux. Okay, a magnetic flux means what, guys? Let's say this is your particular conductor. Okay, conductor is nothing, it's the material which can conduct or which can provide path to the electricity. Okay, so let's say this is your magnet. Okay, and magnet is producing magnetic field like this. Okay, and how much magnetic field is line or you can say how much magnetic field lines are passing through this conductor, okay, at a particular point. Okay, let's say there is a point A. How much magnetic field are passing through this magnetic point, okay, this point here A in the conductor. Okay, the rate with which that magnetic field lines are passing through this point are called magnetic flux. It means that, if you simple language I can summarize it like this, magnetic flux is nothing, how much magnetic field lines are passing through a conductor. Okay, just simple, keep it like this. Okay, and B over dt. Guys, what does this mean? This means that this, okay, this is what? Electromotive force. Like what, say, let's say this is your magnet, okay, and this is your coil. I'm just, guys, in this time simply explaining you what is the basic concept. Okay, you just summarize it in your mind. This is the electromotive force which will be generated in the magnetic coil I am talking about, okay, with respect to which we are changing the magnetic field. Okay, so EMF will be induced in this coil. EMF, simply, if you do not want to conclude or confuse yourself with EMF, you just think that this is the current produced in the coil, and this is the magnetic, okay, with which is changing their magnetic field. Okay, this is the flux, okay, d phi b over dt. This flux, this is the rate of change in this, guys. Magnetic field lines are changing where? In this coil. Okay, so magnetic field lines when are changing, magnetic field intensity is changing. Okay, so it will leads to what? Current in the coil because of this moving magnetic field. Okay, so these are two concepts, Faraday's law and electromagnetic induction concept. Okay, now let's understand the third concept, guys. I told you that whenever there is a changing magnetic field, okay, it will leads to what? Current. There is a vice versa also, guys. When there is current change in a particular conductor, okay, when there is a current change in a conductor, that will also leads to what? That will also leads to generation of the magnetic field. Generation of magnetic field. So guys, these are the three concepts that we have used there. First, what I did, electromagnetic induction concept. Second, I told you Faraday's law. Okay, and third, I told you what, guys? It's a, you can say, when there is a magnetic, magnetic dipole. Don't be confused, guys. Magnetic dipole is nothing like, if I explain magnetic dipole in terms of that coil, okay, let's say this is your coil and you are passing a current through it. Okay, when you are passing a current through it, okay, because of the direction of this current, we can say this is the north pole and behind it is a south pole. Means a coil behave like a magnet when there is a changing current flowing through it. Okay, so these three are the concepts which are used in the wireless charging. Let's explain how. See, guys, you have seen, let's say, let me explain with an example of phone. Okay, let's say this is your phone, okay, and here is a coil set up in your phone. Okay, let's say if you check out the iPhone recently launched by the Apple, okay, you will see that there is a circle type or ring type of behind it. Okay, so there is a this, let's say this is a coil, and let's say this is a charger. Okay, charger, and this is connected with the electricity, current is flowing through it. What I will use all the concept which I told you just. Okay, let's say current is flowing through this charger. Okay, let me change the color, and let's say, okay, this current is flowing through this charger. Okay, guys, when the current is flowing through this charger, what is this? There is also a coil like this. Okay, when the current is flowing through this coil, I told you guys, current is flowing through the coil, it means what? It will generate what? Magnetic field. Okay, magnetic field. I told you that it will behave like a magnetic dipole. Okay, when the magnetic field is generated by this charger, what will happen? This will generate like this magnetic field. Okay, like this, and when these magnetic field lines are getting in the contact with that ring which is there in the phone. Okay, when these magnetic field line will get in the contact with this ring which is in the phone. Okay, I told you that when the magnetic field lines will get or will change with respect to that ring. Okay, I told you that ring, there is a change in the flux of the magnetic field which will leads to what? EMF, means current. Okay, current generation, and this will leads to the current generation in this coil which is established in the phone. Okay, and that current is used, okay, that give the power to that phone to work. Okay, that will give the power to mobile. Okay, it's a similar concept, guys. Okay, it's just that we are neglecting, or we are just replacing the wire, okay, that is direct contact of electricity from charger to that phone. We are just replacing that thing with the help of magnetic field. Okay, so it means simply, guys, you will see here, okay, current is passing, current is producing magnetic field. That magnetic field is creating a current in the another coil, which coil is here in the phone. Okay, so this was the simple concept, guys, how the wireless charger works. Okay, so this is all about. And guys, this is a very interesting fact. Let me share a very interesting fact with you. When this invention started, okay, electromagnetic induction, this concept, when the scientist found it, it was a very simple experiment like this, guys. What they did, they took a coil, okay, and they also took a magnet. And what does that scientist did, he just passed that magnet through this coil. Okay, he just take the, let's say it's a copper coil he take, okay, and he passed the magnetic through magnet through this coil. Okay, in between this coil. Okay, he just pass out it here back and forth, okay, between the coil. And he noticed a very interesting facts like this, a current generation, there is some change in the wire. Okay, and guys, see, this was the simple accidental, we can say, kind of experiment he did. But now there is various kind of application that we can use electromagnetic induction in various concept, guys, various concept. And it may be the reason that in the future you will see that there is like in the present time, if we see the range, okay, the distance range between the charger and the phone is very small. In the future there is, you can say, a very high possibility that we can even increase this distance too much. You can say that in the, it can be happen that we can generate this even for kilometers. It may be in the present time it's not possible, but in future it may be the reason, or it can be happen. Okay, so this was all about that, how the wireless charging works. Okay, and this is the craze in this time in the electronic industry. Okay, I hope you like this video. If you like our video, then give a thumbs up and do subscribe our channel. Thank you so much.